Just getting set up here. But welcome if you're here for the post Code Forces round stream. I'm gonna update the stream title so that people know what this is. This contest stream. Usually 102. Alright. Hey Atharvax, welcome to the stream. And yeah, I'm gonna just get set up here in a sec. And then I'll start going through the problems once we have a couple people in the chat. So yeah, just sit tight. Hey everyone, welcome to the stream. I'm just setting up still. Code Forces educational round. Nope, that doesn't look right. Nope, that doesn't look right. This looks right. All right. Resize my windows. Alright, so you guys can see that my performance this contest wasn't the best. I did not end up getting G, though I do think I know how to do it. How did you guys all do? Post your results in chat. You can hear about how everyone was doing. Alright, you say bad? I'm sure you did alright. Maybe not your best contest, but I'm sure it was a respectable performance. What did you guys think of the problems? I thought they were nice. They were harder than I was expecting, so. Especially problem F and G were challenging. Currently crying? Yeah, no, I feel the same, honestly. I'm not used to only solving 5 out of 7 on educational rounds. I think I usually try to do better. I still don't know what my problem is on G. Yeah, same here, Arya. I would have solved all 7 if I didn't get interrupted by pizza. Yeah, no, pizza is the bane of all competitive programmers' existence. I do want to upsolve G. I feel like I'm like maybe 1 or 2 lines away. I'm really close. It's just FFT. Oh, Vashmi, congrats on solving B. Vamshi, first time solving B. That's a great achievement. All right, we got a couple viewers on the stream. Let me know if any viewers, come in late and you want me to go over something again. Just let me know. I'm gonna go ahead and get started. So let's start with problem A, and I'm also going to show my terminal. Well, I guess I'll just show it in a separate tab of Chrome. No, I'll show it in my terminal. So let me cast that, and then I'll explain the problem. Okay, so what we got here is problem A, and my code is currently the wrong one. Let me fix that. Okay, so problem A, replacing elements. Let me make sure my stream is set up correctly so that you can all see my code. All right. So yeah, problem A was a pretty nice problem. You have this operation that you can do, which is choosing 3 distinct indices I, J, and K. And then what you do is you take a sub j plus a sub k, you compute that sum, and you replace a sub I. Sorry, one sec. Is my stream set up weirdly? Hey everyone, no low quality video. Letters way too small. Okay, let me increase the font size for now, and I'll look into why my thing doesn't have a low quality setting, because I thought I fixed that the other day. Yeah, sorry if the text is hard to read. I'm trying to fix that, and do let me know if it gets better or worse. My stream settings, video, I'm doing 1920, so that should be possible to downsample on client side, but just let me know if that doesn't work. Is this a bit better? I'll move my face around so that it doesn't block anything important. Upright. Low quality is available? Okay, great. That's good to hear. Let me know if there's anything that isn't legible. Okay. Then I'll move right on to explain problem A. And questions in chat I'll get to in a sec. So yeah, you have one single operation you can do, which is take three distinct indices I, j, and k, and assign the sum of aj and ak to ai. And can you make all ai lower or equal to d using the operation above any number of times? What this means is you have an array, for example, the first sample, you have an array 2, 3, 2, 5, 4. And I'll write this in the comments here. So sample 1, array is 2, 3, 2, 5, 4. Can you make all elements less than d plus 3? And yeah, can you do this? Turns out answer is no. No matter what you do, the 5 and 4 are too big and you can't replace them. The smallest sum you can replace them with is 2 plus 2, which is 4. So hopefully this gives some intuition for what the solution looks like. Oh yeah, I need to fix the code forces. It seems like my stream is no longer there. Thanks for the reminder. I think I just have to edit this to say that it's still going. Yeah, thanks so much for the reminder that my stream is not shown on code forces. Maybe if I say 8:45, 8:46, people will come. All right, and you all, okay. That is now, right? I wonder why it's not showing up. Anyway, let's just continue talking about the problems. Hopefully it shows up eventually. I'll set it to like 6 minutes in the future, and that should maybe help. But yeah, unfinished box. Ah, very smart, very smart. Then I can turn this back down. Thanks so much for the advice. I have a lot to learn about Codeforce's streaming. Cool, it's showing now. Thanks everyone. Okay, sorry for the interruption. For problem A, let's continue on. We got some intuition. So like intuition, we want, so array elements that are already less than d are okay. Otherwise, we only need to consider replacing with the sum of the smallest two elements. Because you would never want to replace an element with the sum of two larger elements, because you could always do something smaller, basically. And this is just like, this is known as a greedy argument. Proof for why this works, a bit hard to formalize. I guess not hard, but just I won't formalize it, but should be intuitive that this works after playing around with the problem. And yeah, sorry if that's not as rigorous as you were expecting, but I do want to get to the other problems and move on to the implementation of this. So yeah, all you have to do is check that if there are any elements greater than D, that they can be replaced by the minimum of the two, minimum of the array. And the difficult part here is, like, you want to implement this elegantly. So the way I did it was I first sorted my array after reading it in, and then for every element after the from index 2 and onwards, I replaced it with the sum of the first two, if it was better than what it currently was. Then I checked if any element was greater than D, and then I set it to no if it was greater than D, and I printed out the answer. So yeah, formalization of problem A is left as an exercise to the viewer, and let me catch up on chat to see if I missed any questions. So yeah, a lot of people also did this. They sorted the array, checked A0 plus A1, handled the corner case. Yeah, someone asking if I have Vim template or coding template. Yeah, coding template, just look at my submissions on Codeforces. I'm Stephen K+ on Codeforces. And let's see, a video on my setup of Vim. Maybe I'll make a video on that sometime on YouTube. Thanks for the suggestion, Ryan Hansek. Enable slow mode in Twitch chat or people will spam a lot. Yeah, maybe I'll do that if there's more spam. It seems okay right now. Can't we replace all elements with smallest sum? Yes, exactly. That's the solution. And then we just keep doing that. And yes, I will be uploading this on YouTube, so look out for that. XCrushZ, what are these comments in my template? Yeah, this is just for me to stay organized. Book code is stuff I copy paste. Solution is stuff I write from scratch. This is just so that I know when I'm checking over my code which parts I don't need to read as carefully, because book is stuff that I've probably tested before. What is my YouTube channel? It's in my Twitch about, so if you click on my Twitch profile, it should show up there. But yeah, great. No other questions about A. I'm gonna go on and look at problem B now. Okay, string LCM. How did you guys all do on this problem? This problem was a bit harder than the first one, but it was nice and hopefully pretty straightforward once you've made some of the basic observations. Oh yeah, drawing tablet. I have a drawing tablet now, so I should use that. I forgot about this Jamboard. Hey, can you guys all see this? All right. Cool. Yeah, I just haven't I haven't set this up, or I didn't set this up today for some reason. But I can share this and make this public to the internet, so everyone can see this, can view this. Okay, let me know if that is helpful. If you want to follow along with any diagrams I happen to draw. Cool. So, string LCM. Let's talk about this problem. A multiplication of a string is the same as the way it works in Python. So you can take a string, multiply by a number, and it repeats that string that number of times. Neil Wu, did I wake up 20 minutes late for the contest? Yeah, you caught me. I did wake up 20 minutes late for the contest, which is why I didn't solve G in the end. I was really hungry, so I made breakfast, and then I did not. It tanked my performance, I would say. Yeah, don't do that at home. If you're participating in a rated contest, start on time. Don't be like me. Oh, I shared my email. Oopsie daisy. I think you guys could have found it eventually anyway. Yeah. Okay, so LCM. The question is, given two strings S and T, find the LCM of the two strings. And least common multiple of strings, they define it to be the smallest string, the shortest string, that is a multiple of both. So let's go to the drawing board and talk about the first, let's talk about all the samples. So, let's see. How do I use this? Okay. Samples. We got BABA, comma, BA. Answer is BABA. And this makes sense because BABA is a multiple of both BABA and BA. Cool. And then the next one is AA, comma, AAA. This becomes just 6 A's. And this is the shortest string that is a multiple of both of these. And you can tell because the length is 2 here, and the length is 3 here, the length is 6 here. No other number, like if you have just a string of length 5, you know that's not a multiple of either of these. Because to be a multiple of a string, oh, zoom out, yeah, my bad. To be a multiple of a string, your length must be a multiple. So let's write that down. Key observation. So I'll do key observation. To be a multiple of a string, your length must first be a multiple. So this is a key observation which should be fairly intuitive to prove or to understand, because by definition of multiplication of strings, the length also multiplies by an integer multiple. So yeah, this is the key insight. And you can use this to basically say, okay, well, to find the LCM of two strings, you just first take the LCM of the lengths and then see if you construct a string of that length, if that is a valid LCM. Okay, so let me switch over to to my code, where we can write this in a bit more rigorous, slightly more rigorous. And I'll probably re-implement my solution because it was really bad. So key observation. S can be a multiple of T. String S can be a multiple of T only if len s is a multiple of len t. And that's the first key observation. The second key observation is if like k, or if s and t have the same length but are not equal, then they have no LCM. So what this means is solution, given inputs s and t, or let's call it a and b, first find k equals LCM len a len b. So we first find the length of the candidate LCM, then test that a times k over len a and b times k over len b evaluate to the same string. If yes, print out that string. Otherwise, report no LCM. And this is the solution I recommend because this makes use of both observations, right? First, we make use of the first observation that you must have, if you are to be the LCM of these two strings, first of all, your length must be the LCM of the two lengths. Maybe a multiple of the two lengths, but it turns out from the second observation that if the LCM doesn't work, then any multiple of the LCM, in other words, any other common multiple, not necessarily the least common multiple, any common multiple will not work if the least common multiple does not work. And yeah, the way I implemented this was kind of terrible. I think a better way would be like int k equals n over GCD n m times m, and then we do something like string canned canned2, and we would do like k over n canned1 plus equals a, and then do the same thing for b, and then we check if they're equal to each other. Something like this. And I'm not going to actually run this because it's probably not complete, but this is the way I would do it if 0, yeah. This is the solution I recommend, but the way I ended up doing it was, just a bit different. Cool. So yeah, I could explain the actual solution I implemented it, but I really don't recommend it. The only way I did it this way, implemented this way, was I thought we were computing GCD of strings. I misread the problem. I really thought we were doing GCD at first. Hey, NikkiFu97, will there be a replay? Yes, I'll post this on YouTube when I'm done. Some other implementation notes. Well, I noticed that the limits are really small. Like the length of the strings are up to 20. So that made it really easy to brute force. You can just try a lot of candidates without worrying about time limit. So yeah, this solution that I wrote was like O of n squared, it looks like. So it really would have worked up to lengths of 1,000, 2,000, 3,000. That would have been totally fine. Cool, so that's problem B. Let me see if there's any more questions. I think the key example was the second one, AA, AAA. This one really gave the intuition for, all you have to do is check the lengths and then make sure that the strings actually work when you construct the string of that length. All right, let's move on to problem C. Problem C. Oh, this problem. This one gave me some trouble. This one gave me some trouble for sure. No more inversions. Let's read the problem statement together. You have a sequence with n elements, and the way the n elements are defined is you first go from 1 up to k, and then you go back down until you've hit n elements. So k is, between n, at least n, and at most, n is at least k and at less than 2k, which means at most the sequence can go back to 1, but it won't go to 0. And now you want to construct a permutation of length k. So a permutation over k, not over n. Sorry, let me catch up on the questions. No9_1_1, can you explain why you loop till 30? Yeah, I could have looped to just like less than or equal to 20. All I want to make sure is that I try all multiples of a. This is trying a times I for all I in 1 through 30. And it's because I know that the answer is going to be a multiple of a, and you're not going to be much more than 30. Can I go a little bit faster? I'll try to strike a balance based on all my viewers. I don't want to go too fast or too slow. Since we're on problem C, I'll finish explaining it, and yeah, I'll try to go a bit faster. Okay, so yeah, you want to find a permutation of size k, and using that permutation, you build a sequence of b in the following manner: bi equals pai. So let's try to break down what that means. Let's see if I can use Jamboard for this. Paste the problem statement, paste the input details, and I'll draw on this. So this is my first time trying this, so forgive me if I mess up. But okay, how do I enter drawing mode? P? Is there a shortcut for that? Okay, pen. Okay, so let's mark this up a bit. So input 1, 1. This means that the sequence is just 1. And that means that there's not much you can do because your permutation must be just 1. Not very interesting. 2, 2. This is the array 1, 2. And there's nothing you can do here because if you were to permute it, it would become 2, 1, and this is bad because it has too many inversions. But then 3, 2, this is where it gets interesting. This array is 1, 2, 1. And you actually want to map it to 2, 1, 2 because the number of inversions is the same in either case. Just one inversion, either case, either way. And this is why the answer becomes 2, 1. And then for 4, 3, I'm trying to stay a bit organized. The array is 1, 2, 3, 2. And again, the answer is you swap it to 1, 3, 2, 3 using the permutation 1, 3, 2. So there's some observations that we can make here. Seems like you always do, like if you have like x plus 1, x plus 2, ... back down, x plus 1, x, you always map that to like n minus 1, ... x, and then back up to n. This is not a very legible way of writing it, but basically, if this is your array, you map it to this. This is a pictorial representation of the array. This is probably easier to understand. So why does this work? Well, this is just a guess. This is a guess at what the answer looks like. is we always take this symmetric part and we flip it upside down. And the reason I think this works is, note that if you have two numbers which are equal, then as long as you keep them equal, the number of inversions that they contribute will never change. My face is coming in the way. Let me just move this over here. So if you have a subsequence A, B, A, this always has exactly one inversion. And this is actually like a fairly rigorous argument that I just made. Is that you always have exactly one inversion if between any three elements where the first and third are equal. Because, if A is less than B, then the BA pair is an inversion. And if A is greater than B, then AB is an inversion. Yeah, so this is a proof that the flipping idea works. Because basically what I claim is, because we have equal elements that contain other elements, they will contribute a constant number of inversions relative to any third element. So if you have a square, a circle in between, and a square, this is always exactly one inversion. So for all of these triples, like we can partition all the possible pairs of elements in the array, all n choose 2 pairs. We can classify them as either the pair is among like somewhere in the first section and somewhere in the second section, in which case it's not an inversion. It might be completely contained within the first section, or it might be completely contained within the second section. And if it's completely contained within the second section, we can partition those pairs into like these AB, BA pairs, in which case you know exactly one of them is inversion, and it doesn't matter what you do to this array. So yeah, this is how you prove that this is a valid flip that does not increase inversions. Now, how do you prove there's no alternative to the flipping idea? Let me actually make a new page, because I want to explain this better. So, plain. Solution is always flip the symmetric suffix. And again, I'll draw this diagram. Goes to this is our array. And oh, I need to move my face again, don't I? I'll just make my face smaller. It's just getting in the way. And the reason is any pair I comma j, if we'll call this part A and this is part B, and there's a dashed line here. If both in B can be partitioned into pairs ij and ji prime, where our I and I prime are the pairs of elements that are corresponding to each other. And this has exactly one inversion. So yeah, the proof is basically like we cannot decrease the number of inversions because of this fact. So, cannot decrease number of inversions via permutation. And that's why the solution must keep the first few elements constant. Because if we move any of the first A elements, we're going to increase the number of inversions. And that's why the solution must be to flip the symmetric suffix. All right. Let me show you the code now. And maybe write some more notes. Yeah, you can tell that the code is very short. Sorry, I have to show the code. Yeah, so I'll rewrite some of this in code, in text, because I think I do a better job of being precise in text. So basically, 2 observations. 1, in a subsequence A, B, A, there is always exactly 1 inversion, regardless of whether A less than B or A, B, or yeah. And 2 is number of inversions cannot be decreased because of the observation 1. So best we can do is keep it the same. And the only way to keep it the same is to use a permutation P that fixes 1 through x minus 1. Or, okay, now we introduce some notation. Let v equals 1, 2, 3, dot, 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 x plus 1, dot, 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 n, dot, 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 back to x. So yeah, our permutation must keep 1 through x minus 1 constant. As long as that is true, you can, P can permute x through n arbitrarily. Since it can be arbitrary, pick the one that yields lex max result. That is, so yeah, these 3 observations yield a solution. The answer is 1, 2, dot, 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 x minus 1, n minus 1, dot, 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 x. Okay, so yeah, typing it up, I think I agree, is probably easier to communicate exactly the statements that I'm making. I will try to find a balance between drawing and typing, just because, yeah, drawing is much more difficult on a computer than on actual pencil paper. So I need to, I need to keep that in mind. Yeah, reading through the chat. Yeah, understanding this question was harder than coming up with a solution. That definitely felt true to me as well. It took a while. And then, yeah, drawing on a screen, I need a lot more practice, especially for graph problems. Yeah. All right. But yeah, any questions about this problem? Thank you for the compliments on my notes. I'll try to predominantly stick to typing, and I'll draw only if it's something you can't easily type out. I'll try to avoid handwriting. I'll try to stick to diagrams, visual diagrams with the pen, and typing for text. Why does n minus 1 x work? It's because anything works. Anything works for the x through n part, and that's because of observation number 1, that given 3 numbers where the outer 2 numbers are the same, there's always exactly 1 inversion. And then that means of all the possible pairs that might be inversions, you can kind of match one pair to its twin, the twin being the corresponding, like if you take in an example like x comma n, there's a twin n comma x, and between every pair and its twin, there's exactly one inversion. Okay. This was a nice problem. I really liked the observations that it required, and I thought it was really simple how, or I really liked how simple the final solution was, because all you have to do in the end is just print out 1, 2, and then x minus 1, and then print out the reverse. So the way I implemented it was just using, I first wrote the numbers 1 through k. This is k. I wrote numbers 1 through k, then I reversed x through k, and then I printed out the answer. Okay, let's move on to problem D. Problem D was pretty tricky as well. It's definitely not a super standard problem. Sorry, one final question from Ribley Kexko. What is x? X is k minus n minus k. It's the last element of the array. Okay, so problem D is about a program. Your program is given as a string of minuses and pluses, and as you might expect, the minus decreases your counter by 1 and the plus increases your counter by 1. So pretty simple. That's a program. And then now here's a tricky part. You're given m queries. M is up to 200,000, and each query is saying, okay, here's two numbers L and R. We're going to take all of the instructions between L and R inclusive and ignore them. So we're deleting a subarray of the instructions, a substring, and then of the remaining characters in the string, we're going to interpret that as a program, run it through, and then ask the question, how many distinct values does our counter ever take on? So let's unpack that a bit. We have a constant string, and then we want to be able to answer questions of the form, given a subsequence, which is like a prefix plus a suffix, the result of deleting a substring is a prefix plus a suffix. What is, I guess, like the max and the min? Or what is the difference between the max and the min? And that is equal to the number of distinct values. Because x is continuous and integer, so you can just look at the bounds to know how many distinct values it spans. And this is not an easy problem because the bounds actually are pretty tight, or at least like they require a subquadratic solution. You have 200,000 commands, you have 200,000 queries. You have to do this in like something like log n time per query. Fortunately, though, I did come up with a solution, which might not be the best solution. There might be a simpler one that takes advantage of the prefix suffix nature. There almost definitely is a better solution than this, now that I think about it. But the way I did it was by making the observation that there is some group action going on here. So let's start typing. And let's also show my code. I used the seg tree, but let's make some observations. Each command, or commands compose in the following way. Or I guess the data of a command, or yeah, let's track this way. The data that we need to track to fully represent the action of a string of commands is the following. The cumulative sum that the string of commands contributes plus plus minus goes to plus 1. Man, my formatting. And then the minimum value that is taken on during the commands, e.g. plus plus minus is 0, achieved at the start. Oh shit. I'm sorry, I forgot to change my window size. Thanks for the reminders, guys. I need to read chat more. Is this better? Can you guys see what I've been typing? But yeah, this is a pretty nice problem. I think it's very instructive because it's a very fundamental kind of question. You're just given the structure of operations, try to encapsulate it in a data structure that you can like efficiently implement queries on. So I guess like observations, it's a data structure problem. Try to try to succinctly represent the structure of the problem so that it can be thrown onto a seg tree. So yeah, I need to read chat more. Yeah, I do. I didn't miss anything else, hopefully. Okay, so yeah, let me recap. The way the problem works is we want to be able to efficiently ask questions and answer questions about substrings. So the things that we are concerned with are substrings. That means we need to find a way to efficiently think about taking two strings and adding them together. So we need to be able to support composition of commands. Composition or concatenation, that's the same thing. We want to be able to think about that in a logical way. So what does it mean? It means we have to be able to track the cumulative sum. So we have two strings. If we track this cumulative sum of each individual string, it's very easy to perform the operation join. So I guess like what we need to say is all data tracked needs to be, we need to be able to compute or maintain values under the concat operation. And yeah, what we need to answer in the end is the minimum and maximum. And the motivation here is really, we first want to know the minimum and maximum, because the minimum and maximum, that's what feeds into the final answer, right? The query is asking how many distinct values. That means we need to know the min and max. That's why we start with min and max, and we think about this. Okay, if we want to be able to do min and max, what else do we need? We need sum, because to join node left and node right, we're going to return result, and we're going to say result.min equals min. And it's not this. It's not just the min of the two, because the right string only gets applied after left has completely been applied. And this is the key. This is the key part to understanding how associativity works in seg trees. Is like, this is a non-commutative structure, but it is associative. You know, it's still composition of like functions. Composition of functions is always associative, but it's not commutative. It has to be left.sum plus right.min. And then it's easy to do the same for max. We just replace the word min with max. And this is the defining characteristic of the problem. It is the heart of the solution. Allows us to just use segtree to finish it off. Someone heard my Facebook notice. That's kind of funny. Okay. Looking forward to an exclusive segtree stream. Sure, yeah, maybe one day. I don't consider myself like the expert on segment trees, though I think I know enough about segtrees to do a small stream on it. But yeah, what you want to think about when trying to use segtrees is this thing. How do you concatenate, right? You want to first think about what do you need to know in our answer. In this case, it's min and max. And then how do we get that? Well, we have to come up with a definition of a node. We have to come up with a set of data to track, to maintain, and figure out how the concatenation works. So of course, we can also do res.sum. Yeah, so it can also work with prefix and suffix. That's true. The structure that you're exploiting when doing prefix and suffix is still this kind of, you still have to make these observations of this is how concatenation works. So yeah, you could compute like all the prefix nodes and all the suffix nodes. I did segtree, but yeah. We could have done here, this is segtree way. We could also do ans2 equals prefix L plus suffix R. This is prefix way. And you could pre-compute the prefixes, probably in a very straightforward manner. I'll just go ahead and implement that right now. We'd want prefix of I plus 1 is prefix I plus node of XXX, where X is this value. And then we do the similar thing for suffixes, but in the reverse order. Yeah, so 2 ways to solve this problem. We have to make sure we do this in the correct order though. And I think they're both pretty much equivalent. This is like alt solution stuff. But it still utilizes the same structure. It still uses the same way of combining nodes. But yeah, the key is understanding that it's non-commutative. You have to do left plus right. You can never do right plus left. What is node? Yeah, sorry, I kind of skipped through parts of this code. But here, node is the struct that I defined. And it's exactly what I described here. It tracks sum, min, max. And then the way they combine is this way, as follows. We add the sums. This is sum. Well, I guess that's obvious. We take sum plus sum, min of a min, and a dot sum plus b min, min of a max, a dot sum plus b max. So you can construct xxx becomes node res dot sum plus, like in general x y z, res dot min equals y, res dot x equals z. And that's in C++, unpacks structs defined with in the order that fields are defined. This is because it's one-to-one with mem layout. So yeah, this is just like some syntactic shortcuts that I'm taking, Cabo. this is why can I just do node of x comma x comma x? It's because I'm using this trick of struct unpacking. Liar who seeks truth. How many years am I into algorithmic problem solving? 10 years. But yeah, so anyway, to recap this problem, the key is figuring out the node. Once you figure out the node, you solve it using data structures. You can use prefix suffix. That's one type of data structure. You can also use segment tree. It's a more general way to solve this problem. It would support querying middles of the array. It's a bit overcomplicated, but that's what I did. I used efficient and easy seg trees as my implementation guide. And yeah, I had to do some trickiness to handle the non-commutativity. And yeah, the prefix suffix solution is much shorter. It looks like this. You just compute prefix sums, suffix sums, and then you add prefix and suffix to handle the query. Hey Gabu Pro, do we have a stream after every Codeforces contest? You know, that seems to be the trend these days. It's yeah, I think it's likely that most streams will have most contests will have a stream now. Yeah, liar who seeks truth, list initializer. Yeah, that's a good point. Known as list initializer. Thanks for giving the term. That's if you want to Google it. Max minus min, will it work? Yes, max minus min plus 1, because you want to include the max in the count. All right, so that's problem D. Let's check in on the system testings, or I guess they already finished this testing because it's an educational round. Let's go to problem E. Unless there are any more questions. Problem E, I quite like problem E. This is about shortest paths. And this is a nice little spin on this standard shortest path problem, where we're taking the sum of the edge weights on the path, but then we're subtracting the maximum edge weight and adding the minimum edge weight. So this is a very interesting formulation of it. One observation is this max and this min, we're subtracting the max and we're adding the min, and overall we're trying to minimize this overall sum. Right, so one thing we could do is kind of move this min out. So this is actually something I want to draw for. So this is problem E. And this is kind of the way I think about it. Max, negative max, and positive min, move these to the front. This is kind of like rearranging, I don't know, what's it called, like reducer slash quantifier? Quantifier, if I had to give it a term. This is probably not the most accurate technical term for it, but basically we get max over we're trying to take in the end minimum over all paths I and j of sum of path length minus edge I plus edge j. So basically what I've done is I've reformulated the problem to be, instead of, find this of all the paths, find the sum, which itself contains max and mins inside of the definition, and I've hoisted up this the max and min part into the outer min statement into like what we're taking the min over. So there's 4n, or there's like n squared times number of paths to check, instead of checking each path and then checking n squared things. Okay, so this might not have been super clear, but the reason this is important is now in our graph, which might look kind of weird, but let's say this is a source node. The only thing we have to think about now is what node are we at, and have we subtracted an edge yet? And have we added an edge? So the intuition that I tried to explain on paper is the only thing we have to track, the only questions we have to ask about our state, if we're treating this as a graph search problem, is what node are we at, have we subtracted an edge yet, and have we added an edge yet. Let me switch to the text editor, because this is something that's easier to formalize and rigorously state in code. So observation. Problem is asking about, let me zoom in a bit here. The following quantity defined for a given path P. Sum path length minus max edge along path. So plus min edge long path. And the key observation is you can reformulate this as asking about the following. What is the minimum value of the following expression in term taken over all choices of P, I, J? Path length of P minus edge I plus edge J, where P contains edge I and J. And let me rename, this is deleted, and this is duplicated. So yeah, the observation here is we can reformulate the problem so that we only have to think about deleting and duplicating edges. In particular, we've relaxed the conditions of the problem. We can duplicate any edge, and we can delete any edge. This makes it easier to this simplification makes it easier to compute the answer without changing the fact that the answer, or without changing correctness of the answer. So yeah, it's saying like we might duplicate if we duplicate something that isn't the max, or that isn't the min along path, then answer won't be optimal. So won't affect our final answer anyway. So this is like basically saying, since we're finding the shortest path, the conditions in the problem will be satisfied by virtue of that minimization. So like, since we are minimizing the path on the transformed graph, that minimization implies three things simultaneously. Path length minimize, which is the like original target of minimization. Subtracted edge maximize, which is constraint number 1 that we had relaxed. And duplicated edge is minimized, constraint number 2 that we had relaxed. So yeah, this is like kind of a trick. So by virtue of minimization, like our answer is optimality, we've also, it is also valid. Yeah. So yeah, this is kind of a trick that is common in, I guess, graph problems, where you want to transform the graph so that you get a new graph structure that you can actually work with without, breaking the correctness of your solution. And this like might remind you of like this like pattern of optimization reminds me of Lagrange multipliers, but there's a lot of ways you can think about this. Cool. So what does this mean? Implementation. Before, like, we have input graph G gets transformed to H. G has n nodes. H has 4 n nodes. Each node of H maps to node in G, comma, has deleted, comma, has duplicated. So yeah, we have 2 squared times n states. Exactly. That is exactly right. Sleep is sheepy. We have one value corresponding to a location, a pointer to the original graph. That's n choices. And we have a Boolean for whether or not you've deleted anything. That's 2. You have another Boolean for have you duplicated yet. That's another 2. So 4n. And then edge weights, as usual. Add an edge from n comma I comma j, sorry, has duplicated, to n comma 1 has duplicated with 0 cost, or with negative cost. Or sorry, that's not right. I to j with 0 cost for all ij in original graph. And add an edge from I has deleted 0 to I has deleted 1 with 2 w cost for all ij w. And keep like I a b goes to j a b with w cost. This is the standard. Yeah. Cabo 25, do you play chess? Yeah, I do play chess. I'm not very good though. Liar who seeks truth. Your post-contest streams are most informative and detailed. Thank you. Oh, thank you. That means a lot to me. I am pretty new to doing these explanations, so please do give me feedback. I know I I know that my streams aren't always the most smooth in terms of having a story to tell or like explaining the solution clearly, and I get distracted a lot. So just let me know, give me feedback. I'll try to improve. Hopefully my streams get better and better, and it becomes more and more helpful to everyone. So yeah, this is the description of, this is not really like an implementation, but description of graph transform. And actual implementation, remember to use long. And having written that, let's look at the code. So I'll walk through it. We read in the inputs, very standard, NNM, edges, taking all the edges. This is called adjacency list, because it's a list of edges, or a list of lists of edges. So you can index into a node to find all its edges. This is all very standard. This is how I write Dijkstra every single time. I use an adjacency list. I use a priority queue. PQ is up here. What am I doing? Yeah, so the type def of priority queue is this. This is just to make it so it's sorted in reverse order. That's what greater means. It means this is the comparator it uses. It sorts things earlier if it's greater, or later if it's greater in this case. Because by default, priority queue is a max heap, but that's details. We have a priority queue of pairs of longs, and here I wrote in my notes, and this is again something I often do when I have complex state to be tracked. I just describe it, how the pair is set up, what my data structure looks like, and the ID is this mapping from 0 to 4n to my n comma a comma b, where a and b are my two booleans. And then, standard Dijkstra. For each node in my transformed graph, there's 4n of them. I track its distance, the best distance I've seen so far, and then every time I visit a node, I check if the distance is better. Let me delete these print statements. I check if the distance is better, and if it is, if it isn't, I return. So if it is, I update the distance and I enqueue the node to be visited with the correct distance. And then, I initialize. This is a source node. The initial state is 0, 0, because we haven't skipped anything or doubled anything, so that's the zeros here. And then, as long as my priority queue has more nodes, I just keep visiting things. Traverse all the edges. I iterate over all the possible next states. Discard invalid ones, because we can't go back once we've skipped, or once we've doubled. Once we can't go to a state where we haven't. But we can go forwards. This is what the forwards case is. If we are going forwards, we get, it implies a change in the edge weight. We either increment or decrement depending on which one we're changing. And it's possible to do both at the same time. That's something we have to account for. It's not an else if, it's an if. And then, yeah, standard Dijkstra stuff. And then the node we want is, the state we care about is the one with both booleans set to true. That's why, so +3. Hence +3. And yeah, that's my solution. Let's see if there's any chat. Oh geez, I forgot to move this up, didn't I? Please scroll down. Yeah, I think I fixed it, but basically I was walking through my code, I have my priority queue, and that's, yeah, the transformation is the key to the solution. And then the rest of it is just how to implement Dijkstra, which is all here. This is Dijkstra. The only part that might be interesting to you is here's where the graph transform is encoded. Graph transformation on edges is implicitly encoded in the following lines. Yeah, transformation was the solution. So this is just implementation. One thing I want to highlight is I did this as a way of kind of simplifying my mind, is iterate over all 4 possible edges and then discard the ones that are invalid. It's a bit easier to think about. I also use these are integers, right? This is the number of times we've skipped, and this is the number of times we've duplicated. It's like a bit easier to think about than Booleans if you're trying to do accounting like this. But yeah, this could have also been like times NA minus A. This is like equivalent. It's the same thing. Cool. Yeah, sorry for messing up the stream layout thing again. I need to check the chat more, or also monitor my broadcasting software. Yeah, if I can post these detailed solutions, it will be helpful for Upsolving. That's a great idea. I think I'll put these on Gist on GitHub, and I'll write a comment on the actual announcement with all the solutions. I think that is probably how I'll do it. So yeah, I'll write a comment with a link to my YouTube, the Gist that contains all my solutions, and then maybe any diagrams I drew, but I don't know how useful these will be. But thanks for that. With a link to problems submissions, either Gist or CF submissions. So diagrams, YouTube. Yeah, I can submit as well. I didn't really, yeah, I guess I have all these notes in my solution, so I'll just, yeah, I can just resubmit these. That's a good idea. Cool. Yeah, thanks for the suggestions. I'll definitely do that. Finally, let's move on to problem F. Or maybe not, I don't know about F because I didn't solve it. Let me know if you guys want to hear F. If not, I want to talk about G really quickly, because I think I actually made some non-trivial progress on G. And I know that these later problems, a lot of people didn't get a chance to read them yet, so, and they're also harder for sure. So it might not be as informative or valuable to go over them on stream. But yeah, I want to talk about my solution to G and maybe even fix it live, because I want to know what my issue was. So let's just do that quickly. This is problem G, and I'll take some time to read through it. Question in chat from Vatsal. Any other problem you can recall which requires such ORs graph transformations? Oh, there's tons. This is a very standard flavor of problem. There's a lot of problems that are just Dijkstra, except you have to use some kind of tricky transformation. Let me see if I can use code. There's probably a list of them somewhere. Silver graph. Huh, maybe it's in gold now. But yeah, this is definitely, there's definitely a lot of variations on this. So yeah, any of these will probably require Yeah, I just linked it in the chat. There's a use code guide, which is how I learned this stuff. So if you want to get more practice doing Dijkstra problems or graph transformation problems in general, this is good for getting, I guess, fluent in graph transformations. And I'm sure these are all like, shortest paths, but graph transformations are a more general class of problem, but this is a good place to start. Yeah, use code guide, highly recommend. It's work in progress, but it's already really useful. Okay, problem G. Problem G is asking, given this diagram, how many ways are there to go from the left to the right if you can only move from one tile to the next if they're touching, and you can only move to the right? So the way I approached this problem is I started by kind of annotating this. There's one way to get here, one way to get here, one way to get here, and obviously this is Pascal's triangle. But you can notice there becomes a key divergence from Pascal's triangle coming up. This is getting smaller now. Sorry, this is 10. Undo. The number of ways to get to, I'm writing down a number of ways to get to each of these squares. And this is the end of the first A equals 4, B equals 2. Yeah, so this is how the problem G works, is you're given a sequence of A's and B's. Every time A equals like something, you just expand that many times, and B equals something, you shrink that many times. You have this nice little guarantee that A and B are going to be pretty close together. And in the structure, it's very combinatorics. It's very combinatorial. You can literally see Pascal's triangle here. So the way I approached it is I looked at every number and its contribution. I looked at every number and its contribution to the next iteration, basically, and noticed that it was a convolution of two arrays, the current state array and just a bunch of like binomial coefficients. So let me start writing this down. Define a generation to be a list. I guess let's compute for each generation the number of ways to reach each cell, where a generation is, occurs after B operation. And then the way to go from one generation to the next is a matrix transform. But furthermore, this matrix transform is convolution. Number of ways, or coef, So yeah, so solution, pre-compute all factorials, so you can do n reciprocals, choose in O1, and then use FFT to go from one generation to the next. And yeah, it's actually really simple. You just use FFT and you use the formula that we wrote down. The formula is go for a generation A comma B and previous state V0, V1, dot, dot, dot. Next state W equals WI satisfies W's WI contribution of VI to WJ is WJ plus equals, and I had this written down here. It's just B plus I minus J times you have to go left, and A plus B steps you have to make. Or sorry, B plus, yeah. Go right, B plus I minus J times. Go left, A minus A plus J minus I times. Going left, keep index constant. Going right, increase index. Or this is opposite, decrease index by 1. Keep index constant. And yeah, this is all it needs. And then it's just a matter of implementing this. And then I took too long to code this up. You know, I do think I could have finished this if given another like 10 minutes. Probably should have woke up on time. That probably would have helped. But yeah, this is the entire thing. What I did in contest was I implemented the naive solution, which takes like 8 billion ops, because sum of 5i squared, or I equals 1,000, is 8 billion. And this is too slow, so I tried to change it to FFT. I copied some code from Bank. You can see Bank code that I just stole from his like. I have this bookmarked from his GitHub, but I took too long to adapt it. Like, I'm not used to Bank code. I have to write a lot of new macros just to be compatible with his code, which, you know, definitely slowed me down. So maybe I should organize my book a bit and have an FFT ready to go, because I don't have FFT in my book. So yeah, that's my lesson learned, is to get better at FFT. Even if I get theory, actually implementing it needs to be a breeze for it to be useful. But yeah, that was my contest experience. Thanks to everyone who stuck around in the stream. And as always, please give me feedback to if there's any tips you have on making my streams more entertaining, more informative, more educational, anything. I always want to improve, so yeah, thanks for all your feedback there. M0K, if you're just joining, the contest that I just went over is Educational Round 102 from Code Forces. So I can paste a link to that contest if you want to see the problems. And This is kind of near the end of the stream, so if you want to watch from the beginning, it will be posted on YouTube, or you can watch the VOD after the stream is over. Dash 1729, no problem. Yeah, stream's about to end. Well, I think I'm going to try to fix my G first, and then if you guys want to watch me do that, you're free to stick around, but I'll probably not be explaining as much as usual. This is, yeah, at the end of the official educational post stream. Unless anyone wants to see F, I don't know how to do F, so I wouldn't be able to explain very much. Let me know in the chat if you want to see F. Can I give a brief on shortest paths? Well, the link I sent was just a list of other shortest paths problems. If you want to learn the actual content, I think that link has a description of Dijkstra as well as links to other resources to learn Dijkstra. TLDR for Dijkstra is single source shortest path. It solves that problem. You have a graph, positive edge weights. Blue guy wants to see F. Oh man. I just did not get very far in F. Is my screen cut off? Yeah, definitely not. It's because my window sizes are different from usual. But yeah, now it's a bit better. F is just a variation of some min flow. Okay. Well, at least I can say that for F, I wrote notes on paper. And the notes I wrote for F, let me see if I can get on camera, is build DAG, flow question mark, hard. So I'll say I got that correct. I recognize it as a flow problem, and I had no idea how to actually do it. So I'll take partial credit. But yeah, flow problems, not my kind of thing. If you force me to write flow, I probably could do it. It's just the intuition for flow is not very natural to me. I don't have a lot of practice doing flow. Partly because IOY doesn't have flow problems. I never really trained them. Also, it's just very confusing. But yeah, I imagine you just want to delete a bunch of stuff, and that's the min cut. I probably won't go over F. Just okay. I'll read the editorial, I guess. So there's this @coder problem which was linked in the chat. In the editorial. Oh, is it in Japanese? Oh God, I don't know if this is. Oh, here we go. Okay. Okay, so the graph construction is n plus 2 vertices. You label them, ST and then 1 through n. And then you add edges from multiples with infinite capacity. And then the minimum cut is you have to make sure in your cut, I guess, where's the problem again? Okay, so you're minimizing how many elements to exclude, and you want to exclude everything that you can as long as the condition is still met. Oh man, I can't do this problem. I get this. The theory is you define a graph, you add edges from source to node, from node to sink, and then between nodes. And then the exact edges you add, I have no idea, but unknown blue guy, I'm sorry I'm not more helpful. I didn't solve this problem in contest, so there's not really much I can help with. I think the structure is very similar to that editorial though. You just construct this graph, define network flow, and then solve the flow using like Dinic, presumably. Dinic's algorithm. Alright, I'm going to go back to solving G. Once I get this, I'll probably end the stream. Helped all of us enough, thank you. Thanks for saying that. Yeah, I wish I solved F. I did spend like maybe 5 minutes thinking about it. And I realized it was going to be not my style, so I moved on to G. Alright, so what am I doing wrong? I'm multiplying things, and it does not look to be working correctly. How do I fix that? So I think it's because I'm unfamiliar with the book code. Multiplication assumes what? What is size? Oh, this code is so hard to read. Wow. How does Bink do this? How does he do this? But yeah, it's not working. The book code is not working. I'm multiplying two arrays, v times mult, and I'm getting w2, which is completely wrong. It seems to be multiplying by 4 instead of by 1. So that's kind of bad. I must be using the code wrong. I must be misinterpreting the way I'm supposed to be invoking mul. Because I'm multiplying v by mul, I'm getting something completely wrong. Do they have to be the same size, maybe? No, it's doing the resize, and then it should work. I'm gonna use someone else's book code. I'm sure there's another one somewhere. Is there a number theoretic transform here? F-type. Yeah, this is double. I want number theoretic. This is still complex. Oh, fast. Oh, this is so much easier. But this includes fast Fourier transform.page. Okay, I'm gonna just open this up. This is Cactal. I can use Cactal, so I just need content numerical. This is a stress test. Content numerical fast Fourier transform by and fast Fourier transform by. So these are the two things I need. Conv mod and conv. Vector C So it still uses FFT. That's kind of strange. Are you sure this works? Oh, is this how it works? As long as n times mod is less than this big number? Okay. We're gonna try this. Goodbye, bank. Sorry, bank. And we're gonna use Cactal, which will hopefully be a bit better. What is M here? Where does it do the roots or whatever? This is different. I feel like this is different from what I actually need. Oh, I don't know how to do FFT. What kind of questions involve FFT? Questions where you need to multiply polynomials efficiently. FFT is good for polynomial multiplication in n log n time. My savior, Ekner-Wallace Ekner-Wallace FFT. That's always something I can rely on. Oh, it's beautiful. It has everything. Oh, there we go. It's even namespaced nicely, so I can just copy paste it into my program. Oh, yes, includes modnum, but I have modnum already. Ekner-Wallace, my favorite. The best feeling in the world is when you read Ekner-Wallace code. See, all I have to do. Ooh. What is this? It just compiles, see? No compiler errors at all. Now I just have to fix all this stuff. Mint using. Okay. Reading Ekner-Wallace code. ACL? What is ACL? Man, Favre, you're very knowledgeable about library code. I've never heard of ACL, and I don't know how to find Ekner-Wallace code. Oh, ACCoder. Oh, right. This is the new one that they are using for their judge, right? That you can just include as part of the library. So how do I invoke Ekner-Wallace FFT? Is there an example? It's probably just multiply, right? Okay, and where do I set the mod? Struct complex. Where's mod? Primitive root int mod. Oh, okay. So I want FFT multiplier. Okay. So I want something like this. Ekner-Wallace : FFT : FFT mod. Mod. Is this right? Oop. Okay. What is this? Type name struct FFT multiplier. Namespace FFT. Type value. Template parameter. Okay, let me just compile this. Or let's see if there's anything wrong with this. I'm gonna see the full. Oh wow, Ericto raid. Hello, thank you, Ericto. This is a nice raid. um, I'm trying to upsolve problem G right now because I ran out of time in the middle of the contest. I was trying to borrow BankQ's code, and I was unable to figure it out. So I'm trying to figure out Andrew's code now. Okay, so I think I can't do this. Maybe I can do a pound define. Huh. I had a stray semicolon. Okay. Is this better yet? Type name num. So what is num? Oh, this needs to be int, maybe? That must be it. But then how does it know what the mod is? Like, how does it find the roots? Yeah, Bank and Eknerwala, they're making sure they hold your top 10 ranks. They're like, hey, you should use my book code so that in the contest, I beat you because you don't know how to use it. But nah, I'm just trying to figure out, like, don't they need to find primitive roots given the type name num? Or are they somehow able to unpack that? FFT num. Are they doing roots anywhere? Oh, they're doing roots implicitly. Get root. Oh, I see. Get root you implement intelligently because it knows that. Oh, I see. Okay. So it implements get root for mod num. Do I have to use the same mod num? I have to use Ekner-Wallace mod num maybe? But this is Ekner-Wallace mod num. I'll just move mine into his namespace, and then I think that should work. All right, it compiled. Yeah, my mod num template is actually stolen from Ekner-Wallace. I just took out the namespace. Ericto, yeah, when do educational rounds have such hard problems? That's what I was thinking too. Like, problem F was a flow problem, which I don't know how to do in general. And problem G is FFT, which clearly I also don't know how to do. But let's see if I can get this working. Do I just call it? Or... Hey, Ericto, curious if you're still here, what FFT do you use usually? Multiplier.multiply. What's mod multiplier? Oh my god. I don't know the difference. I want FFT mod multiplier, I think. Multiplier. You use your own FFT? I see. How do you, I guess, do you implicitly figure out the roots like live, or do you hard code those as constants? Okay, so I have to provide the input lengths. Doesn't like it still. Trigonometric values. So you never do NTT. So do you need NTT for this problem? I'm not familiar enough with the difference between like FFT mod and NTT to know when it's necessary. I have no idea what I'm doing, man. getting other people's book code to work is actually so hard. Is this what I have to do? Oh my god. Why does Andrew do this? Andrew, why are you like this? Okay, but let's see if that works now. My god. Like, are you guys seeing this? Andrew expects me to know to use .begin for everything. Like, why can't you just take in the vector and just, like, why'd I have to tell you the size? The whole point of a vector is to have a size. All right, am I passing yet? So W2 and W are not correct yet. And the reason is my formula is wrong. So the formula I'm using, so Ericto, did he participate, Ericto? Oh, you didn't participate, I see. Did you submit for any of these? No, okay. You brute force just computes convolution with integers, and you can always use real values, but you will get precision errors for big values. So if the mod is just like 998 and your numbers are up to, n is up to 5,000 here, that's probably fine, right? 5,000 times this is 5e14, which FFT double precision, complex precision can't handle. So I think, yeah, Ericto, so do you think for this problem it would work if the maximum intermediate value equals mod times 5,000? That should work for just regular real value FFT then, right? You don't need NTT. I see. You have to be tricky if you want to use FFT, like maybe divide by 2 or something, because exploit the symmetry. X times 3, 0, 1, 2, 3. Oh, like, oh, that, I see. So kind of like, almost like big number style, like you have a radix that you use to make your intermediate values smaller. I see. Well, good thing I have Andrew's NTT. I think that's what I'm using here, mod multiplier. This better, oh wait, this is still double. Does he have NTT? Oh shoot, yeah, I'm still using his. So I think I actually want his FFT multiplier, not mod multiplier. Eknerwala. Yeah, I'm gonna spend some time reading through APL. Atcoder library seems like probably well designed and easy to use. Yeah, now I need to figure out how to set up my convolution to be correct. So I want this to range from 0. My multiplication is wrong because I'm first. What am I even doing? Maybe subtract y? I think I got the FFT part at least working. I think now it's just like I have to figure out what inputs to feed into FFT. I just haven't done that correctly yet, so I'm working on that now. Am I passing samples yet? 1561, 181, 215. Okay, I'm getting there. I feel like I'm getting closer. So I think here I want to do plus x minus 1. $396. I'm definitely getting closer. 1561. Okay. Wait, why is my answer wrong now? So I sent in, hey, see you, Ricto. Thanks again for the raid. So I sent in a slow solution here, which just implement this naively. I wonder if I can use this as a reference to see what I'm doing wrong. Oh, I got it backwards here. This is j minus I. So I might need to reverse again. Can I upload this to YouTube? Yeah, I plan to upload this stream somewhere. Let's make sure this still works. And then W. 2. $850, okay. Okay. Why is this 2015? I'm gonna use some scratch paper. LRNQ, what's the lower bound for CF rating to become a mod on this channel? Are you asking what is the current min of the mods for this Twitch channel, or like in the future? Because I don't think I have an answer to the second question. I haven't come up with a policy for mods. Yeah, maybe you can DM me and we can talk about it. I haven't checked your profile yet, but if you're excited to be a mod, maybe I don't know if I have a very strict rating requirement, so. 15, 20, 15. Okay, so this is incorrect. This should be 6 choose 2, 6 choose 3, 6 choose 4, 6 choose. Okay, we're getting somewhere. W2 is always containing this. So this needs to be offset by X. Are we there yet? We're there yet? Oops, this is too short. Doesn't need a -1. And I think we got it. Okay, so we're gonna comment out W and submit this now. I think I finally got the formula correct. So, oh no, compilation error. MPy. How do I get MPy? Math.h. How do I include things? CMath? I haven't included something in so long. So bits. Pro, yeah. You do, I do see you a lot. Okay, MPy. I'm just gonna do pi. And then in my book, I'll do const double. Pi equal big host -1. I just really want this to pass so I can move on. But this was an instructive problem for sure. I'm learning a lot about FFT and stuff. Alright, seems like we're doing pretty well so far. Running on test 130. Accepted. Alright, so thanks so much to Ericto for the raid. That definitely pushed me over the line to get AC on this problem. Yeah, kind of stumbled a lot with just libraries and knowing about FFT and stuff, but cool. We finally solved G, so it's good. Validates that at least I know how to solve it in theory, even if my mechanics are a bit off. I don't really know anything about Andrew's code, so maybe I should get him on a call next time to ask him. But it's magic. Eckner-Walla code is magic. It always works. You just might have to figure out how to use it. That's the only difficult thing. But yeah, thanks everyone for tuning in. I'll be posting the YouTube video on my channel, which is in my Twitch channel about page. And I will also upload any notes, code I have to, code forces, and then link that in my comments. All right, everyone. See you next time. And hope you enjoyed my stream. As always, send me feedback if you have any suggestions or comments on my on how I do my streams. Thanks, everyone. Bye-bye.